In today's note, we are going to continue to look at completing the square. However, now we're going to look at situations where the a value does not equal 1. Now, for the most part, the steps are going to be roughly the same. There are going to be a couple of new steps to account for that a value not equaling 1. So I'm going to go through the steps first. We'll work through a couple examples. I'll let you try a couple on your own, and then we'll come back together and we'll work on a word problem. So the steps, the first step is group the first two terms, the x squared term and the x term. So again, this is very similar to the last one. The new step, or something that's new, is that we want to factor the first two terms so that the a value is 1. So we're going to have to do some common factoring here to get that a value to equal 1. Once that happens, we need to make a perfect square trinomial inside the bracket. So this is going to be the same thing as last time, where we find the magic number by dividing the second number, or the x coefficient, by 2, and then squaring it. We're then going to add and subtract the magic number inside the bracket. Again, the same thing as before. We're going to move the subtraction outside of the bracket. Same thing as before. However, when we move it outside the bracket, we have to multiply it by the factor, or by the common factor that we had took out previously. This is because that common factor applies to that number, so when we take it out, we have to reapply it. And then finally, we're going to factor the perfect square trinomial and collect the like terms outside of the bracket. So just two separate things, or two different things compared to the last lesson. And in this case, it is involving common factoring and then reapplying that factor. So going to work through the first one. Y equals 3x squared minus 6x plus 13. So again, the first step, the first thing we want to do is put brackets around the first two terms. The second thing we want to do is now we want to common factor the first two terms, so that the value in front of the x squared is 1. So in this case, I need to factor out a 3. Still going to have my bracket, and then inside, I'm going to have x squared minus 2x. So again, just common factoring. If you need to refresh yourself on common factoring, again, please go back and look at a previous lesson. But we're just common factoring the first part. Now we can make a perfect square trinomial inside the bracket, similar to the steps that we did before. So the third step is to make that magic number by taking that middle number, so negative 2, divide it by 2, and then square it. So here we have negative 1 squared, which equals 1. I'm now going to put that number inside that bracket. I'm going to add and subtract it. So plus 1 minus 1. The plus 13 is still on the outside. So that was step 4. Step 5, that value inside the subtraction, that's going to come out. So 3 is still there, x squared minus 2x plus 1. But when I move this minus 1 out of the bracket, I need to reapply that factor that I took out. So that 3, I need to multiply it by that negative 1, or that negative 1 I need to multiply it by that factor, or 3. So in this case, when I move it out, it becomes negative 3, which is just the 3 times negative 1. And then I have plus 13. And then the final step, step 6, is the exact same thing as the last or the previous lesson. That inside the bracket, that should be a perfect square trinomial. And if we need a reference for what that number is, we can look at the second step of our magic number. So it should be x minus 1 all squared. And we collect our like terms outside the bracket. So minus 3 plus 13 is plus 10. And now I've completed the square, and I have my equation in vertex form. And now I can see I have an a value that's other than 1, because again, we're dealing with an equation in standard form where the a value does not equal 1. So a few extra steps, but essentially it's the same thing. Example 2, or B, we're going to go through the same thing, work through the same steps together. So the first step, put brackets around the first two terms. Second step, I need to common factor the bracket so that the value in front of x squared is equal to 1. In this case, the number in front of x squared is 2, so I know I need to have to common factor a 2. So when I common factor the 2, what's left inside the bracket is x squared minus 5x. Basically divide everything inside that bracket by 2. And I have the plus 9 outside. My third step is to come up with my magic number. So I need to take the x coefficient, or negative 5, divide it by 2, and then square it. So in this case, I get negative 2.5 squared. And when I do that, I get 6.25. So 6.25 is my magic number. So now, step 4 says that I have to add and subtract that magic number inside the bracket. So we get x squared minus 5x plus 2.5, or sorry, not 2.5, plus 6.5. Let me get the right colors. Again, plus 6.525 minus 6.25. And then we still have plus 9 outside the bracket. The fifth step is to take that subtraction, move it outside of the bracket, but when I do that, I have to reapply the factor, so I have to multiply it by 2. So I get y equals 2, then inside the bracket, x squared minus 5x plus 6.25, then outside the bracket, I have negative 6.25 times 2, obviously negative 12.5. So again, that comes from negative 6.25 times 2. And I have the plus 9 still attached. Finally, step 6 is to complete this, or is to factor the perfect square inside the brackets and collect like terms outside. So I have x squared, or sorry, 2 times x, and then minus 2.5, because again, that 2.5 comes from that second part in my magic number, squared, and then we have negative 12.5 plus 9, or we have negative 3.5. And there we have our quadratic in vertex form. So again, very similar steps. We're still trying to find that perfect square trinomial. The only difference here is that we have to common factor first, and then when we move the term outside of the bracket, we have to reapply that factor. So C and D are two more examples, again with a value in front of x squared that is not 1. So I'd recommend you pausing the video and trying these on your own. We will come back and I'll walk you through or show you kind of a brief outline of all the solutions, and then we'll get into a word problem together where we can again do the same thing, work through completing the square to help us find our vertex form. So coming back to these two examples, these are the two solutions that you should have. So in C, again, going through the steps, put brackets around the first two terms, common factor it, find your magic number, add and subtract that magic number. When you move the number outside of the bracket, reapply that factor. We have to move that subtraction out. and then factor your perfect square and collect like terms, and you should end up with y equals -1 x minus 5 squared plus 21. Again, this one might have been a little bit tricky because looking in front of that x squared value, you may not recognize that the a value does not equal 1. Right? It actually equals -1. So we still have to do it this way where we factor out that -1 first. So just keep that in mind. The only time we go back and do the steps like we did in the previous lesson is when a does not equal, or when a equals 1 only. Right? So a has to be +1. -1 doesn't count because, as we see here, we have to use these new steps. For d, again, same thing. Put brackets around the first two terms, common factor them. In this case, you're common factoring a 5. From there, find your magic number, add and subtract it, move the subtraction term outside of the bracket and reapply the factor that we see in orange, and then factor your perfect square trinomial and collect like terms, and you should end up with y equals 5, x plus 2 squared minus 18. So again, hopefully you tried those on your own and you're feeling a little bit more comfortable with it. They are the exact same steps as the previous lesson, so hopefully you see some repetition and you become you're a little bit more confident with completing the square. So the last example is a word problem, and we're going to look at it, and again, it's going to follow the same idea. It's just more about recognizing that we have to complete the square. So the cost C in dollars to hire landscapers to weed and seed a local park can be modeled by C equals 6x squared minus 60x plus 900, where x is the number of landscapers hired to do work. How many landscapers should be hired to minimize the cost? So here, the key thing that we should be looking for is the fact that we're looking to minimize the cost. And anytime you see a question with quadratics where you're looking for the maximum or the minimum, where you're trying to maximize or minimize something, you should be looking for the vertex. Remember, the vertex is that highest or lowest point. It does have the optimal value, which is your max or min, and then depending on what you're looking for, you may be looking for that y value. You may be looking for the x value, which is what we're doing in this case, because x is the number of landscapers. And the question is asking how many landscapers. So when we find the vertex, we will be able to know what the minimum cost is, as well as how many landscapers are required or need to be hired to get that minimum cost. So coming up with our equation, we have again C equals 6x squared minus 60x plus 900. The only issue is this is in standard form, so I don't have what my vertex is from this form. Luckily though, I can complete the square so that I can turn it into vertex form and find that vertex. So again, just going to go right through the steps. So I'm going to put brackets around the first two terms. Second step, I'm going to common factor them so that the value in front of x squared is 1. In this case, I need to common factor out a 6 so that I'm left with x squared minus 10x. And then the plus 900 is outside of the bracket. The third thing I need to do is find my magic number. So I need to take the x coefficient, or -10, divide it by 2, and square it. This leaves me with -5 squared, which is 25. Step 4 says to add and subtract these two numbers back in to the bracket. So x squared minus 10x plus 25 and minus 25 plus 900 is still outside the bracket. Step 5 says to move that subtraction outside and reapply the factor. So 6 times, in brackets still, x squared minus 10x plus 25 that minus 25 has moved outside. And if we have minus 25 times 6, we get negative 150. And then we still have the plus 900. Then finally, in our last step, we're putting it all together. We're factoring our bracket into a perfect square, which we can get the value. It's going to always be x or whatever this variable is. And then the number from our second step in the magic square. So x minus 5 all squared. Collect like terms outside the bracket. So basically add those two numbers together and you get plus 750. So we've turned it into vertex form, but we still need to answer the question. We need to know how many landscapers should be hired to minimize the cost. In this case, we're looking for our vertex, and our vertex here is 750. So if you have trouble figuring that out, remember again, the vertex is h and k from our vertex form. But if you have trouble or forget about vertex form, please go back and look at that lesson just to refamiliarize yourself with what vertex form gives you in terms of information about the quadratic. So we know our vertex is 750. If we want to get technical, our 5 represents our x and our 750 represents our cost, or c. So therefore, to minimize cost 5 landscapers, because we said x represents the number of landscapers. So 5 landscapers need to be hired to get a minimum cost of $750, which is our C value. So that's our minimum cost, and we need, in order to get that, we need to hire 5 landscapers. So again, completing the square is the same basically as whether the A value is 1 or not 1. There's two extra added steps, and the whole goal is to get to vertex form so that we can access or gain key information about our quadratic or about our model from the vertex form, specifically that max or min value and what is the x value that's associated with it. But again, as long as you follow those steps, it should be straightforward, hopefully, in getting to vertex form. And again, please review the lesson on vertex form if you are, or if you forget kind of the key information that it gives you.